Hi everyone, I'm just going to get us started on question 6A from the 2022 higher level paper. And just so we know where we are, question 6 is the short question section. It's the starter section B. As you can see there at the top, it gives you your instructions. You answer only 4 questions for this section. That was the rules in 2022. That may change in 2023. That was part of COVID allowances. And each short question, I'll actually go through the marking scheme in a second, but you'll see all the instructions on your paper anyway. I just wanted to show you that so you knew where you were. I'm just going to make it so we just have our question to focus on here. We're looking at question 6A, and let's just get into it. Have a read off it. I'll show you how I tackle these ones, and this is a nice calculation one. So just starting straight away, it says iron has a density of 7.87 grams per centimeter cubed. And we'll have a look at the units as we go. But I like to just mark up the important bits of information on my question. Some people like to use fancy highlighters. You can use a biro, whatever you have in your hand. You don't have to do this. I just like it makes things clear for me, especially when I'm just after sitting down in an exam hall with a paper in my hand and I'm trying to just break it down a little bit. So we've got iron has a density of 7.87 grams per centimeter cubed. That's just a property of the material. Our iron of any shape or size, that's going to be its density, okay? An iron sphere, so like a metal ball, it has a mass of 500 grams, half a kilogram. And the question's asking us to calculate the radius of the sphere in centimeters, okay? And it's important that they said in centimeters. When they have gone to the trouble of specifying in the question what your units are, you must be really careful that you give your answer back in those units, because that's just part of the question. I'm going to do a diagram. I would say it's not super necessary for this one, but it just helps me clarify what I'm thinking about physically. That's not a great sphere, but it'll do the job. And they're asking me, what's the radius of this iron sphere? So my little r for radius is a question mark right now. We don't know, okay? And I like to write down what bits of information we have. And if you are getting kind of familiar with your formula and stuff, you might already know the density, sometimes given the symbol rho, is density is mass over volume. Okay. Now, some people might get this already, but just in case you're struggling with the density volume kind of idea, and I never know which is which, there's a really good example that I like to help me remember. Density is how much stuff is squashed into a given space, okay? The volume is only how much space something takes up, and the density is how much stuff is typically stuffed in. So iron is a metal, it's really dense. It's not the same as like air or a gas. And the example I like is if you think of a football, that's mostly filled with air, and let's say a bowling ball. They're roughly the same kind of size. So we say their volumes are the same. They take up the same amount of space, but a bowling ball, you'll feel it's really hefty. There's a lot more mass in the same space, so its density is really high, and that's the difference. That's a good way to just distinguish the differences, okay? You might not find that helpful. You might already be very comfortable with the definitions, but just in case, you might find that useful. So here's the formula that we're going to use. We've got density equals mass over volume. Now, in a second, you might realize what radius isn't there, okay? But what we need to do is work out the volume of the sphere, and then from the volume we get the radius, okay? So it's, if you spotted that this year during the exam, you were sorted. If you didn't, you might have got stuck. Okay, so I'm going to just write down what we have for this part first. Our density, the question says it. I'm just writing it down to help me remember everything in the one spot. You don't need to even do this. You can just start plugging numbers straight into this equation here if you want to. And my mass, little m, is 500 grams. Now, as you'll see me going through these videos, I will generally always convert back to SI units. So I will be saying kilograms here and kilograms per meter here. But because they're both in grams, I'm kind of happy enough to leave it for the moment. And you might see when it comes out at the end, they're asking me for my answer in centimeters. So rather than going from centimeters to meters to back to centimeters again, I'm going to leave it be, okay? And that's okay to do because they're all in the same kind of ones, right? So I'm going to change the shape of my equation a little bit to make my life slightly easier. And all I'm doing is rearranging. And if you're not that comfortable with rearranging, well, bear with me, you'll see it. But you can also leave it be and just put your numbers into place, okay? I like to rearrange now when it's like letters and put my numbers in. So if this is my formula, I'm just going to put it in a little box. And by the way, I meant to say this is in your log tables. So this is in your tables on page 57. And I would say there's this is one of the ones you probably just know by the time it comes to exam time. But if you don't, or if you're just feeling a bit nervous on the day and you want to double check, it's on page 57 of the logs, okay? And you're allowed to have those in the exam. But when I rearrange it, I'm going to move volume over, going to move density over, and they're basically going to swap places, okay? So I'm going to end up saying that volume is mass divided by density. And thinking of that from a physics point of view, it's how much stuff is squashed into the space. Okay, so we've got the idea of volume. And I have a mass of 500 and I have a density of 7.87. And I'm getting this a bit messy. And that tells me, so when you put 500 divided by 7.87, make it nice and clear, that my volume is going to be 63.53. The points don't work that well on my pen. Okay, and it's centimeters cubed. Okay. If you didn't put the units here, you don't lose any marks because that's not your final answer. You need to have your units on your final answer. But I'm putting it there just to remind myself here that we're thinking about volume. Volume is in either centimeters or meters cubed because it's a 3D shape, okay? And now I have my volume. And you say, all right, but I'm not finished. The question asked me to calculate the radius. So what I'm going to do, I'm actually going to give myself a little more space, and you can use more space as you like. So I have a sphere, a big circular ball, and I know that its volume is 63.53 centimeters cubed. We just worked that out because it gave us the density and it gave us the mass. And I'm here looking for my radius, okay? So I'm going to write that down too, just to make it really obvious for myself. Then my radius is question mark. And I need to then think, and this is where you might have got caught. You need to go back onto your page 10 of your formulas and think about what's the volume of a sphere. And if you know that has the radius in it, we are sorted, okay? So the volume of a sphere, just write sphere because it's not the same for everything. Sphere volume is 4/3 pi r cubed. Now, whenever we're looking at an equation and we're wondering if I can get an answer out of this, what you need to do is check, am I missing only one thing? We're obviously missing the radius. Pi is just a number, it's on your calculator, so we have that. 4 and 3 are just numbers, we have them, and we just worked out the volume. Okay, now there are two different ways that you can do this. They're effectively the same thing. It's just two different techniques of the maths part. From now on, it's basically just algebra. And there's two different ways to work the algebra. So I'm going to do it both ways just to show you. If there's a way that you prefer and are more comfortable with, stick with it. And if you are getting the right answer by doing it your way, that's completely fine. As long as you're doing everything according to the rules and you're getting the same answer every time, you're fine. The first way is the one I like, but I can see why you might not, is I'm going to rearrange the formula, okay? So I'm going to stick it here. Sorry about that. Rearrange formula. Now my writing isn't usually this bad, and I have a sample answer attached with a bit neater as well. So if you're finding my scribbles to be a bit hard to read, there's options for you. So I'm going to write it down again for myself, just to start from fresh. And when I say rearrange the formula, it's just like if you remember your algebra in second and third year. Over here on the left-hand side of my equation, I want that one thing we don't know, which is radius. So I'm going to do some manipulation, some moving around to get that. And when I'm happy that I have that, only then do I put in my numbers. The other way, and I'll do it over at the other side of the page, is just starting by sticking in all my numbers and working out an answer then. So I can do this all in one go, which could be a bit hard to follow. So I'm going to just start it a bit more slowly. because there's a cube here, you have to be extra careful, okay? So what I'll give you, I'll do a bit by bit, okay? Just to be sure. And if you're finding this is fine and you just want to speed up and check it to the end, that's great. Absolutely do that. Skip ahead. You don't need to see me manipulating the equation if that's something you feel very comfortable with. So over here, we've got a 3 and it's a dividing 3 over here. So when it goes to the other side, it'd be multiplying. Or the other way of thinking about that in terms of algebra is that we're multiplying both sides by 3. So if I multiply this side by 3, I get 3v equals 4 pi r cubed. And the 3 is gone from here because if I 3 times 4 divided by 3, I'm going to end up with 4, if that makes sense. I'm going to pick on that 4 now next. I'm going to move it over. It's a multiplier here, which means it'll be a divider over there. So I have 3v divided by 4 is equal to pi r cubed. I think I said squared by oh, but I meant cubed, okay? I'm starting to slant a little bit. I'm going to pick on pi next. Now you could do this in chunks if you felt comfortable doing it, okay? So pi is a multiplier there, it'll be a divider over here, so it's going to become 3v divided by 4 pi r cubed. And we're nearly there. Cubed, okay. If this was square and you wanted to sort of get rid of it, you would have to put a square root on the other side. So the same applies for the cubed, except now we need to put a cubed root, which we only use fairly rarely in physics anyway. So I do definitely want you to be careful about doing that. So if we do that, I get cubed root where I have a little 3 by my root, and it's just something I do on my calculator. I don't need to know anything special about it just now. Is the cubed root of 3v divided by 4 pi is r. Okay, and I like having r on the left hand side. That's just kind of convention, and convention is just that we always do things the same way and everyone kind of understands what we're doing. We're all kind of doing it in a similar way. So I write it here, and finally when we get to this stage, we can stick numbers in, real numbers, okay? But we actually only have the one, we only have the value. So this is how it should look before you start going into your calculator. 3 and up above, if you remember, it's 63.53 centimeters cubed. Pi, and I'm going to have to cube root the whole thing. And again, button on your calculator. Just make sure that you're comfortable and familiar with it, but you don't need to know that much about it. Just make sure that you're able to use it. And here's a perfect example. Like for using these videos, if you get this far and you're not sure what's gone wrong, this is a good chance now to pause it, check it on your calculator, come back, play. Did you get the same answer as me? Okay. So if I do that, stick it all into my calculator and I checked it and double checked it, I'm going to end up with something along the lines of 2.475 centimeters. That's the radius of our sphere. So if you think about it, it's quite a small little ball, definitely smaller than a tennis ball, really maybe more kind of golf ball sized iron sphere that weighs half a kilo, because iron is so dense that you can fit a lot of mass into a small space. Okay, that's method 1. And if you are going, oh no, I don't like that, I don't trust that I could move all that stuff around the algebra style, this other method might be for you. And I'm going to just try and separate them. I'm going to say rearrange the formula or input your numbers. My spelling. And it doesn't matter. People marking your paper don't care which way you do it. It's whichever one you're more comfortable with, whichever one you feel the best about. Okay, so input your numbers is option 2. That means that you start with the formula exactly as you're taking it out of the formula book from page 10, and you put in the numbers that you know. Okay, and you start working things out. So you just start in straight away. My volume is 63.53. I still have 4 over 3, that's just a number, and I have pi, and I have r cubed, which is still a mystery to me. We don't know what that r is yet in theory. You can keep going, leave this one alone for the moment, and what I would do next then, this piece, 4 over 3 pi, work that out on your calculator to get an actual number, as in don't have pi in it anymore. So you literally would put in 4 times pi divided by 3, or if you have, however you're comfortable using your calculator, and fractions, 4 over 3 times pi, and you should get 4 point, and close enough to 4.189, and you still have your r cubed here. Careful not to drop that cubed. The next thing, I'll give myself some space. The next thing to do is this 4.189 we need to move that. We want to always isolate the one we don't know. We need to isolate that r cubed on its own for the moment. So, oops. Instead, you could either say that you're moving something that's multiplying here to a divider at the other side of the line, or you're dividing both sides by 4.189. However, your algebra is kind of set in your head. It doesn't matter too much because the end result is the same. I'm going to have 63.53 divided by 4.189, and that's r cubed. Not forgetting about that cubed, okay? And when I did it that way, I got 5.166. And I'll chat to you about the decimal points at the end, and if I forget, somebody's sticking a comment and I'll come back to it, okay? So I've got a 15.166, but that's cubed. So if I left it at that, I would be wrong. That's actually cube of the radius, and this is where I still need to come in with my cubed root on my calculator, my little 3 and my root. 15.166 is r, not r cubed now anymore, okay? And I'm just going to move my r over here because that's how I like it. And I should come out with the same answer as I got over at the other side, doing the same thing, just a different method. And I'm going to double check how I look there. Centimeters, yeah, we're looking good. And centimeters is so important, especially because they asked you in the question, they actually said to give your answer in centimeters. Now, I did remember, so when it comes to decimal points, I don't think you need to have dozens and dozens of them. Really, if you're given in the question something at the start that said the density was 7.87, they gave you 2 decimal points. You can't really be much more accurate than that because you weren't given any more extra information than that. So I've left at 3 for this one, and I think that's loads. So that's the radius of your sphere when you go back up to the question, and this is a good habit always, guys, is to go back. Have a look, even for these short questions, you might be flying through it trying to get yourself started into the exam and save yourself time later, but just go back to the question. Iron has a density of 7.87. A sphere has this mass. Calculate the radius in centimeters. Yeah, I did it. Perfect. I have it done. Okay, so I like that kind of one because it's a calculation. Someone else might hate it. But hopefully now that we've gone through the video, you can see how to do it. If you don't know, or if there's a bit that didn't make sense to you, please let me know. I have the email there, and I have all the social medias and stuff to get contacted. And also, if you found it useful, pass it on. Okay, so we're really just trying to help people figure out how to do their physics questions, and I hope you found it useful. Thanks very much for watching.